Thanks, Jen. Perhaps the greatest ancient astronomers were the Mayans, who lived right here where I'm standing.
The Mayans inhabited the Yucatan Peninsula in Mexico and Guatemala. These people made astronomical and seasonal observations which rivaled anything seen in Europe during the Roman Empire or the Dark Ages. These amazing people mapped the heavens, they evolved the only true writing system native to the Americas, and they were masters of mathematics. They invented calendars that are still accurate today, and without metal tools, beasts of burden, or even the wheel, they were able to construct vast cities with an amazing degree of architectural perfection and variety.
The largest structure at this site is El Castillo, the castle.
That these temple builders were mathematically precise in their architectural designs is borne out by the natural phenomena which occur during the fall and spring equinoxes. In the spring, as the sun rises, the shadow cast on the steps appear to form the body of a serpent which slithers down the stairs.
Here at Chichen Itza, there is a structure unlike anything else ever created by the ancient Mayans. It's called El Caracol, and it actually looks like a modern observatory.
Its design didn't function the same way as our modern observatories. Instead, its walls contained many windows. Inside the dome, stones could be removed, enabling the Mayan astronomers to observe different parts of the sky. The Mayans looked at the sky differently from any other civilization. Being near the equator, the equinox passages were easier and more accurate to determine because the sun cast no shadow at local noon during this time. They also had great veneration for the Milky Way. They called it the World Tree. The star clouds that formed the Milky Way were seen as the tree of life, from which all life came. The Mayans also had their unique constellations. Like today's zodiac, they had their scorpion. Gemini, which appears to us as twins, however, was seen as a peccary, a nocturnal animal in the pig family. Other zodiac symbols were a jaguar, a bat, a turtle, the tail of a rattlesnake, and a sea monster.
Because they looked at things differently, perhaps it's not surprising that the Mayans had a different mathematics as well. We use a numbering system based on 10 digits, but the Mayans used a system based on the number 20. Sounds a little bit complicated, but in fact it was more efficient for counting than some of the older systems used in Europe a long time ago.
The Mayan counting system required only 3 symbols: a shell representing 0, a dot representing a value of 1, a bar representing 5, and a shell with a dot representing the base number 20.
There are 2 advantages to the Mayan counting system. The first of these is the idea of 0, which many civilizations at that time did not have.
Second, they only used 3 symbols to represent lower and higher numbers. In Rome, multiple symbols were used: I's for 1, V for 5, X for 10, L for 50, C for 100, and M for 1,000. Mayan numbers were written from bottom to top, so the number 19 becomes bars of 5, 5, 5, with 4 dots above the bars. To complete the first set of 20, a dot was raised over a shell-like symbol. To get 21, the elevated placement of the dot remained to represent 20, and a dot was added underneath to represent 21. Then the counting cycle for the next 20 began again.
So what do you think the number 40 or 41 would look like?
In Europe at this time, people still struggled with the Roman numeral system. That system suffered from 2 serious defects. First, there was no 0. And second, Roman numbers were entirely symbolic, having no direct connection to the number of items represented.
So, are you ready for a challenge? Okay. Working together, try adding 21 and 33 using the Mayan system. Then try adding 21 and 33 using Roman numerals. This is a good time to pause the program. So how did you do? Let's check your work.
In Mayan, the number 21 is represented as ... 33 is 2 bars equaling 10, 3 dots for units, and an elevated dot representing 20. Adding together, you get 54, which is 2 bars, 4 dots, and 2 elevated dots. Easy to decipher. In Roman, you have XXI plus XXXIII equals LIV. Unless you actually know what the Roman symbols stand for, you have no idea what you are seeing. In Mayan, you can actually add up the dots, bars, and shells. Mayan merchants often used cocoa beans, sticks, and shells to do these calculations. From these three symbols, the Mayans could do everything from the simplest arithmetic needed for trade to keeping track of astronomical events, both past and future.
Speaking of astronomy, remember how I said the Earth's axis was tilted at 23.5 degrees? If you round that to 24, how would you write that in Mayan? The Mayan system of counting using dots, bars, and shells can be compared with the ones and zeros used by modern computers, and it was all done 1,500 years ago. With all the advances that the Mayans made, it's interesting to speculate what would have happened if the Mayans had sailed east to discover Europe instead of the Europeans sailing west to discover the Americas.
To learn more about Mayan mathematics, go to the following websites.
Back to you, Jennifer.
Thanks, Stan. Well, guys, that wraps up another episode of NASA Connect. We'd like to thank everyone who helped make this program possible. Got a comment, question, or suggestion? Well, then email them to connect@larc.nasa.gov. I'd like to leave you guys with a thought and a challenge. What is impressive about these sites is the accuracy of their observations and the time and effort they put into building these observatories. Looking back at these buildings and places, we see that the ancients had a natural connection to their environments and that they were also capable of high-tech accomplishments in their own times. So now, here's my challenge. How do you think people 300 or even 1,000 years from now will see us through the artifacts that we leave behind? Until next time, stay connected to math, science, technology, and NASA. Goodbye for now.
Finally, they pick one stars up and say, this will be the morning stars. It will give us direction that the daylight is coming. It will give us direction that it's in the east. Then the next one is the evening stars. It will tell us it's in the west direction. It's almost nighttime. Deliberated more, like the Dipper and all that. It revolves in different position. It will tell us if it's fall, spring, or summertime, wintertime.